forgot my topical math joke. So Noah and the animals were getting off the ark, and Noah says, "Go forth and multiply." So a little while later, Noah goes and checks on the animals, and all the animals are doing all right except for the snakes. The snakes were unhappy. And Noah says, "Well, what's going on, snakes?" And the snakes say, "We need some trees." So Noah relocates the snakes to an area where there's some trees, goes back a little while later, and the snakes are fine. And Noah said, "Well, what was the story with the trees?" And the snake said, "Well, we're adders. We need logs to multiply." All right, let's get started, folks. Exponential equations. So a couple of our tools. Folks, let's stop talking, please. Our tools for solving exponential equations. We're going to use the one-to-one properties. Our one-to-one properties tell us that if a to the y equals a to the x, or I'm going to take the if away, a to the y equals a to the x if and only if y equals x. 1 to 1. Yes, it's supposed to say 1 to 1. So a to the y equals a to the x if and only if y equals x. And the same, we have a similar property for logarithms. Log base a of y equals log base a of x. And instead of writing if and only if again, the two-sided arrow means if and only if. If and only if y equals x. So that's one of the tools that we're going to use to solve exponential and logarithmic equations. The other properties are the inverse properties. And the inverse properties tell us essentially that inverse functions undo each other. So log base a of a to the x equals x, and a to the log base a of x equals x. So the inverse functions undo each other. One important piece of information about both of these is we need the same base. So we have to have the same base here. These two have to be the same base. These two have to be the same base. These two have to be the same base. So we need the same base to apply these. In general, to solve exponential equations, so this is very similar to solving trig equations, that this isn't a hard and fast rule. It's in general a rule of thumb. We want to isolate the exponential expression. So isolate the exponential function, and then we're going to take the logarithm of both sides. So in general, that's how we solve exponential equations. The other way that we can do this, we can also rewrite in logarithmic form. And sometimes when you do that, you need to use the change of base. So what I'm going to do is go through a few examples, and I'm going to do the problems, show how we can do the problems both ways. Some people prefer one way, some people prefer the other way. Some people switch back and forth depending on the problem. So I just want to show you both ways to solve the problem. All right, so are we good? Okay, let's look at some examples. On all of these, we are solving. All right, so 4 to the x equals 19. We want to figure out what x is. We've already got the exponential function is by itself. So one way that we can do this is take the log of both sides. If we want to plug this into our calculator, we'll take the natural log or the common logarithm. I always use a natural log just because that's more the one that you use, that I end up using the most. So we'll say the natural log of 4 to the x equals natural log of 19. So we're taking the natural log of both sides. Then we use properties of logarithms, turn exponents into multiplication. X natural log 4 equals natural log 19. And x equals natural log 19 over natural log 4. Could do the same thing with a common logarithm. Yeah? Some of them say leave it like that. Some of them say put it in your calculator and evaluate it to some 100th decimal. The other way that we can do this is rewrite in logarithmic form. So how would I write 4 to the x equals 19 in logarithmic form? Log base 4 of 19 equals x. That's another way of writing this answer. But now, if I use, I'm just going to write change of base. X equals natural log 19 over natural log 4. And I get the exact same answer. So if you prefer to think of it this way, you can. If you prefer to think of it that way, you can. If you prefer to switch back and forth, you can do that as well. All right, questions there? All right, next one. Five e to the x plus 2 minus 8 equals 14. So the first thing we want to do is isolate the exponential function. So I'm going to add 8 and divide by 5. E to the x plus 2 equals 22/5. And now I can take the natural log of both sides. When I take the natural log of e to the x plus 2, what do I get? That's just x plus 2. Those are inverse functions, so they undo each other. So equals natural log 22/5. Subtract 2. And that would be my solution. You could plug this in your calculator and you would get that it's about negative 0.518. From here, I can rewrite that in log form. So how would I rewrite this in logarithmic form?
Log u equals 22/5. Log u 22/5.
Natural log base e of 22/5, so natural log equals x plus 2. The logarithm is the exponent, and I get x equals natural log 22/5 minus 2. I get to the exact same place. Sometimes rewriting in log form can shortcut a few steps, but you can think of it either way. All right, questions on that one? Okay, next one. 2, 3x minus 1, 3 to the x minus 1 equals 10. We want to isolate the exponential function. So 3 to the x minus 1 equals 5. So 3 to the x equals 6. Take the natural log of both sides. So this looks like our first one now, just with different numbers. Use properties of logarithms here. And I get x natural log 3 equals natural log 6, and x equals natural log 6 over natural log 3. I could also do this by rewriting in log form. So in log form, I would write log base 3 of 6 equals x. And then I would use change of base and get x equals natural log 6 over natural log 3. Yeah.
Because it's like natural log 6 over natural log 3, can you like reduce the numbers? Like, would you ever reduce that down to like natural log 2?
So that would be that's one of those fake math news things.
I did. It just wasn't a question.
You-
Just a question. So sorry.
And you also can't cancel the natural logs and just say that it's 6 over 3. You can't do that either. All right, questions.
Caroline, do you vote? Would you like better? Would you like better?
Last example. This is my favorite example.
Wait, we're done after this?
Yes.
Oh my god. A whole lesson?
No, just this page. Then he's flipping it over.
All right. Well, this one's a little different. We don't just have one exponential function. We have two exponential functions, but one is the e to the 2x and one is e to the x. What are we going to do here? What is it, Gabby? We factor. This is exactly like we would solve x squared minus x minus 20 equals 0. Except instead of x, we have e to the x. We can think of this as e to the x squared minus e to the x minus 20 equals 0. So how are we going to factor this? E to the x and e to the x. How would we factor this? 5 and 4. 5, 4, minus, plus. We're going to factor this exactly the same way. And this tells us that e to the x equals 5, or e to the x equals negative 4. What's the problem here? E to the x is never negative, right? Our range for the exponential function is y is greater than 0. If we didn't see that, if we took the natural log of both sides, natural log of negative 4, what's the domain of the logarithmic function?
Error.
X has to be greater than 0. This is no solution. This tells us e to the x equals 5. take natural log of both sides, and I get x equals natural log 5. And that would be my solution. And this would be approximately 1.609. Which makes sense, because E is a little more than 2. So 2 to the 2 squared is 4. A little more than 2 to almost 2. It's going to be 5. All right, questions?
Homework.
Yeah. Yes, we do have homework. Good question. To Mr. Who what?